Okay, so to start our Algebra 2 fall semester final review, we're starting with absolute value. Now, absolute value, hold on, pause. Is that not we'll hope it works. Okay, so absolute value, when we have the absolute value of a number, its solution will always be positive. So the absolute value of 9 would be what? Positive 9. And the absolute value of negative 3 would be what? Positive 3. Okay, so let's see down here. It says solve each absolute value equation for x. So when we have an isolated absolute value, that means the absolute value is not being multiplied or subtracted from anything. It's just the absolute value and whatever's inside. We have that equal to 5. We're going to have two solutions, a positive and a negative. And that is because the x value inside the absolute value, whether it's a positive or negative number, it will always end up equaling a positive number. So here we have positive 5 on the outside, but we're trying to solve for x, which is on the inside. So it could be positive, it could be negative. So then we would have two equations, x equals 5 and x equals negative 5. All right, let's look at D. We want to isolate the absolute value. It's already isolated, so we go right into our positive and negative solution. We'll have 2x minus 3 equals 11 on one side, and 2x minus 3 equals what? Negative 11. Good. Go ahead and solve for x. When you are completed, you should see that x is equal to 7 and also negative 4. Those are our two solutions for D. Go ahead and start doing E on your own. We do want to isolate the absolute value, which means we're getting rid of everything outside or touching the absolute value. Okay, so once you isolate the absolute value, you should have the absolute value of x minus 1 equals 3. And now we have isolated, so we start with our positive and negative solutions. All right, so we have x equals 2 and x equals negative, I'm sorry, positive, x equals negative 2 and x equals 4 for our two solutions. Any questions on what we're doing so far? Okay. Okay, go ahead and start F on your own. Again, we need to isolate what's inside the absolute value. One thing we want to think about is we don't touch or multiply or subtract. We don't do anything to change what's inside those absolute value bars. Just think about it this way. What's inside parentheses or inside absolute value? Those items have COVID. And so no one is going inside that house and no one is coming outside of that house. They got to stay home until you can remove the parentheses or remove the absolute value bars. Okay? So as we isolate, we need to subtract 3 from both sides. Looking at this, we have an absolute value equal to a negative number. How many solutions do we have if it's equal to a negative number? 0, good. So just right here, we have no solution. And as a reminder, if we have the absolute value of some number equal to a negative number, this is no solution. If the absolute value of some number is equal to a 0, how many solutions do we have? One solution. And if the absolute value is equal to a positive number, that's when we have 2 solutions. All right, let's take a look at the word problem. The temperature of the wave pool at Six Flags can vary up to 4.5 degrees Fahrenheit from the target temperature of 82 degrees Fahrenheit. Write the absolute value equation and solve for the max and minimum temperatures. So first we have a vary up to 4.5, so I know varies is going to be 4.5. And then we have a target of 82 degrees Fahrenheit. So that's going to be our target. Let's go ahead and plug those into our equation. Well, just like any other absolute value equation, we need to isolate the absolute value. It's already isolated, so we go right into our positive and negative solutions. So when we do the math, we have a range of 87.5 to 86.5. That is our minimum and maximum temperatures. Any questions on that? Okay. Moving down to absolute value inequalities. All right, so looking at the first one, or let's just look at all 4 of them really quick. Let's look at their inequalities. This first one, we have a less than. So this is where you should remember that less than is going to be considered less than. And is a connecting word. So our 2 points will be connected. There is no equal sign underneath that less than, so the circles will not be shaded in. Let's look at the next one. We have greater than or equal to. So we're going to have great or, greater. Or is saying that we're going to have two separate sections going towards the outside, going opposite directions of each other. And there is an equal sign, so that will be two shaded in circles. Okay. Looking at C, we have less than and or equal to. So again, we have less than. So the two points are going to be connected. The equal to tells me that they will be shaded in circles. All right, and the last one, again, we have great or. So we're going to have two separate points shaded in different directions. There is no equal sign, so we will not shade the circles. All right, looking back at the first one, we have an absolute value of x is less than 3. The x is already isolated, so we need to start with our positive and negative solutions. So we have x is less than 3. Who remembers what we do differently for the negative side? With inequalities, there are two things we have to do. Yes. Good memory, Mary. We flip the sign. And what's the regular thing we do on the negative side? Make it negative, yeah. So we have to flip the sign and make it negative. We have our two solutions. So I'm just going to choose two different points on the graph, put -3 and 3, and connect them. Let's say you forgot less than and greater, and you forgot what they mean and how the shading should go. Read your inequality to yourself. The positive one says x, the value of x is anything less than 3. Okay, so I'm not going to shade to the right of +3 because that would be greater than 3. I need to shade less than 3. So that's going to be shading to the left of the +3. And the other one says the x values are greater than -3. So I'm not going to shade below -3. I'm going to shade anything greater than -3. So that tells me that this is a connecting area. Okay. Let's look at B. All right, quick solving. We have an isolated absolute value. So we can go ahead and start with our positive and negative solutions. And remember, for the negative, we have to flip the sign and make the 10 negative. Solving for x, we divide by 2 on both sides. Our two solutions are -5 and +5. So we have great or. Let's think about the inequalities. It says x is greater than or equal to 5. So I'm going to shade everything to the right, everything greater than 5. And we're going to shade everything less than 5. It also says anything equal to 5 and anything equal to -5. So we shade in those circles. Any questions so far?